Hello everyone. So in this video we are going to discuss the code forces round 725 div 3 question number C. So let me check voice is getting recorded or not. Okay, yeah, cool. So in this problem basically what we had to do is that we have been given an array. Okay, we have been given an array and we have to find that the sum of the elements of the array should be between L and R, and we have to count the number of pairs that existed in that array. So as you can see the constraints, n value till 10 to the power 5. So let's see the test cases first. 3 4 7. Okay, value of n is 3 5 1 2, and we have to go to the range of 4 to 7. Okay, and it brings us the answer 2 from this test case 5 1 2, because 5 plus 1 equal to 6 and 5 plus 2 equal to 7, which is inside the range 4 to 7. So now moving towards the approach as well as the code of the problem coding, let's see what is the input in the problem, and let's try to understand uh, how to solve this one. So this basically can be solved using an like an ordered set. Like uh, it could be solved using an ordered set. An ordered set basically is a bit different from a normal set, because in normal set you don't have two functions like order of key, and one more is there, that is find order by. So in ordered set what you do is that every function of ordered set matches with the functions of normal set, but only two functions are exceptional and additional in ordered set. It is also called as policy based data structure. Yeah. So now let's move towards the approach and solution of the problem. So let's see what is given in the input. We have been given t test cases, like 4 test cases, and input is like nlr. So n value is till 10 to the power 5, and l and r value is till 10 to the power 9. So I'll prefer to go with long here. Okay, so n l r, and then we input n l r. Now let's create a vector ll, because uh, it can overflow if we use int in place of ll. So vector vn. Okay, now what we can do here is that uh, just take input from the user. uh, okay, so we have taken the input in the vector. Now what we can do, uh, we can create an ordered set of size of type ll. See, if you have to create an ordered set of type of any type, then you have to additionally add few of these lines, as well as you have to hash include 2 lines of these, and you have to use PBDS, policy based data structures, as well. So using that we have our we have got our array. So now what we'll be doing, that uh, traversing through the array ll I 0, I less than n, I plus plus. Okay, so now what we can do here also, if I take ll, then it is better, I guess. So now what we can do basically, and let's take a result variable as well, in which we could store the result. Okay, so basically what we are planning to do here is, let me make you understand. What we are planning to do here is, suppose we have an array called 5 1 2. Okay, suppose we have an array called 512, and we have to find that how many, like we have to find x and y, where uh, x plus y less equal to r, and we have to find this. Basically we have to find the number of pairs. So what we can do basically is that we can create an equation, we can create an equation like sort of L minus x less equal to y, and r and y less equal to r minus x. Okay, so if we create an equation like that, then I think we are good to go. Okay, what was it, y plus x greater equal to L, so y greater equal to L minus x. Okay, so if we just calculate the values in a ordered set using the order of key function, order of key application of the ordered set, then I think we can calculate the count of the, I think we can calculate the count of the sum, count of this number of pairs which have the sum less equal to r and greater equal to L. Okay, so let me do one thing here, that result, I can store in result one thing, that os dot order order of key, order of key of r plus 1 minus L, and which we will subtract from os dot order of key L minus a of I. Here it will be r plus 1 minus a of I, because we are, what we are doing, we are adding 1 here, because if we want to find uh, suppose we want to find two elements x and y in range L to R, then if we have to find like this, then what we do, then we have to write like this: os dot order of key from r plus 1 minus os dot order of key from L minus L. Okay, if we have to find xy in range of L to R, then we do this. So in the case when we want to find the sum of x and y between L and R, so we will be doing this, and we will add it to our result variable, so that it can calculate and make it a sum and produce the output. And one more thing that we will do, which we will not forget to do, that we have to keep inserting in the ordered set till it crosses n, because otherwise the ordered set will be null and it can throw any garbage value. So we will do like this, and let's see uh, whether it, so let me check once. Okay, so I have declared v, so v, okay, os dot order of key order ll, okay, vector ll lli to, to okay, let's see if I'm done then. Okay, a of I have written here, should be v of I. Yeah, so as you can see that we got here 2701, which is our desired output result. And I can dry run it for you as well, and I can tell you that, for example, I inputted the vector here, and after that what I did is that I just did the order of key of the ordered set, which means that it will find the pairs, but this will find the pairs, some of pairs which exist between L and R. Okay, it will get you the sum of the pair which exists between L and R. Why I did R plus 1 minus V of I? Because R is the range, upper limit of the upper limit given in the question. So R is the upper limit, and I did 1 because it is 0 based indexing, and I did subtract from V of I because if you can see in this equation that if we subtract from, like in this one, we have to subtract from x, so I am subtracting from v of I, which in turn can mean u to be x, because to obtain a third value we have to subtract third value by second value, so we can obtain the first value. Okay, so I want to say that this question can be easily done with this policy based data structure, although this question doesn't require this policy based data structure. This question can also be done using binary search with the help of lower and upper bound, but this type of method always gives us a new insight towards our coding. Let's try to submit this one. Yeah, so it got accepted. uh, so yeah, you can, one more thing I wanted to tell you is that what are the two main functions of a ordered set. Ordered set, two main functions. The two main functions are of an ordered set which is not present in the normal set is the order of key, order of key of n. Suppose if we want to calculate order of key of n, then it means that we are counting all values, counting all values till n, counting all values till n in a given vector. Okay, and one more thing is find order n. So in this, we what we do, we find the element kth element of kth element of the vector with starting with 0. Okay, starting with 0. So these two things only are the difference between an ordered set and an normal set. So this topic comes in DBDS, so everyone should try to learn this type of topic. And thank you for the video, guys. I hope you enjoyed it, learning it. And at last I want to tell you that don't think about, actually it is a heavy data structure, ordered set, but don't think in context that you can't pass the time limit. At least you can try to pass the time limit, because in questions like these, which come in division 3, it's easy to pass the time limit because the constraints are not too high. I mean to say that although my submission also, let me check, my submission also took 248 milliseconds, like sort of, but in normal conditions also, if you give in division 2 it will pass, so no need to worry about using heavy data structures like these. So thank you for the video, guys. Thank you.